The Patent and Trademark Office's examiners typically have to look at thousands of documents to determine whether an application is valid. Thanks to my next guest, they now have artificial intelligence tools to make examinations faster and more accurate. For his work, he's a finalist in this year's Service to America Medals program, and the first of the finalist interviews we'll be bringing you this year, the Director of Emerging Technology and Chief AI Officer at USPTO, Jerry Ma, joins me now. Jerry, good to have you with us.
Thank you, Tom. Good to be on.
Well, tell us what you've done here. There's a lot of paperwork, a lot of it's online, I guess, nowadays, and so how does AI come to bear on patent examinations?
Certainly. It's helpful to start with the fact and the realization that we at the USPTO are America's innovation agency. By our statutory functions and our constitutional mission, we help incentivize and foster innovation across all fields of technology and science, including in artificial intelligence. A lot of my portfolio is about trying to figure out how we leverage the innovations of today to serve the innovators and entrepreneurs of tomorrow. And if we look at the AI community, especially sort of post 2022 with the latest boom in generative AI, there's a whole world of potential out there to harness and to leverage in serving our internal stakeholders, that is our personnel and our expert examiners, as well as our outside stakeholders, that is the general public who relies on us for patent and trademark related services. There's an opportunity to serve all of these communities through emerging modern technology that helps them contend with the increasing complexity of each of their roles within the overall intellectual property ecosystem and help them work more efficiently or work in a higher quality manner, empowered with more information and context, and overall contribute to a sounder IP ecosystem. So a lot of the individual tools that we develop at the USPTO are directed to furthering one of those aims within the context of a specific use case and user community, whether it's our patent examiners who rely on world-class services to trawl through, without exaggeration, tens, if not hundreds of millions of documents spread across multiple databases.
Let's talk about that one for a moment, because, at one time you could go to the library and see most of the literature in paper, or something for a particular innovation. Now, with hundreds of thousands of applications a year, and you say perhaps millions of documents, tell us how you've maybe revved that up so that it's even doable. It sounds like the task could be getting beyond the range of possible without some of these new tools.
Indeed. So this, like many things at the USPTO, has been a gradual progression from what I'll say is a very analog process, or had been a very analog process, to what we see today and what we're aiming for tomorrow. So thinking back to before the age of computers, there was still a need for patent examiners to search, because patent examiners' core function, among their sort of many other responsibilities, one of their core functions is to examine any given application against the universe of what has done before, aka prior art. And certainly before the age of computers, there was already a sort of voluminous collection of prior art in many technical fields, and they had to figure out some way to trawl through that. So before computers, what we did, we had this intricate filing system. Decades before my time, but I hear stories from our veteran examiners about these shoes that they would trawl through sort of in the recesses of our old USPTO headquarters.
They were shoe boxes, not shoes.
You know what? For the life of me, I can't remember why they're called shoes. But it might have been because they resembled shoe boxes or had some other connection. Anyways, this is just showing my relative youth and inexperience. I already am spacing on the etymology of some of this analog technology, as it were.
Sure.
But anyways, we were in the analog world a couple of decades ago. We had a lot of data, but not much in the way of effective ways to trawl through that data. So a lot of our examiners' time was spent just on sorting through shoes, trying to build this muscle memory of like which document existed in which shoe. Sometimes when you took the document out, another examiner who, was relying on that document then wouldn't be able to get to it. So our first phase of modernization and innovation, as it were, was actually well before my time. We digitized these archives and went from this sort of shoe-based manual searching system to a computerized search. And that's sort of already a huge sea change in how our examiners are able to do their jobs and how easy we're making it for them to access everything they need in order to perform their duties effectively. So that's sort of stage one of the innovation. However, stage one still left a lot of things to be desired, because if you think about the state of the art in information retrieval back when we made this first transition, it was by and large all sort of keyword based. And if you think about sort of the revolutions in information retrieval back a few decades ago when things like Google were coming out, those were fundamentally keyword-based technologies. Google's key innovation, of course, was figuring out how to rank the results that were retrieved via this keyword-based retrieval. And they did it very well. And that explains why there's such a big deal now. But keywords can only take you so far, because if it's too difficult to operationalize a concept in your mind or a concept that you see in a patent document with one single keyword or even a collection of keywords, then you're just not going to be able to retrieve everything that you need to make a sound determination. So if there are 5 different ways of referring to a concept and I can only think of 3 of those ways in my head, then those 2 other ways are just not going to be accessible to me. So if there are any prior art documents that talk about the same technology or same concept, but using the 2 words that I forgot about, I'm out of luck as either an examiner or a public searcher. So that's where AI comes in, because AI, one of the things that today's modern AI technologies are super great at, although not perfect, we have issues such as hallucinations and other sorts of errors still, certainly. But one thing that they are much better than the technologies of last generation at is this idea of semantic document representation, sort of semantic representations of meaning. So now with AI, I can either type in a concept or even refer to a concept using other documents that sort of contain or embody that concept. I can turn that into what we call in the AI world embeddings, these points in super high dimensional space, sometimes 512, 1024 dimensions, so not your typical 3D or 4D movie. You put all these documents in these 1024 dimensional points, and then by virtue of the way in which you train these models, documents that are similar in meaning, paragraphs, documents, words that are similar in meaning, will be grouped together in the space. Documents that are less similar in meaning will be grouped far away. And it's through this way that even if I'm searching for the concept of a computer and this other document is referring to a laptop or a mobile processing device, with AI, I'm going to be able to make those connections in a way that keywords would not have allowed me to.
The result is, therefore, that examiners would have access and visibility into much more than they would have by just keyword search. How do you operationalize that such that the examiner doesn't have to be an AI programmer or even necessarily a prompt expert, but can use this capability in his or her daily life, and it's just there giving them better results?
That's a great question, Tom, and goes to the heart of how we develop AI products at the USPTO. So when we think about AI at the USPTO, it's not just about the models and about these high-dimensional embeddings. We're not just thinking about the under-the-hood engine, but we're realizing that around the engine, you actually have to construct the whole end-to-end vehicle, right, that someone can actually use to accomplish their job and do their tasks effectively. So we've invested a ton of effort in making this technology as accessible to end users as possible in a variety of different user interfaces. So, we have one tool where you can just pull up a document and, with a click of a button, and I'm not exaggerating, literally a click of a button, instantly draw these connections between that document to other documents in our database that are adjudged to be similar. So if you're looking at a pending patent application, and being able to make that connection between, again, the patent application, which might refer to computer, and that other thing over there in our database, which might refer to laptop or mobile processing device, you can draw that connection without even thinking about how to do inference on that AI model, because we have basically created the user interface, created the scaffolding above this base, very powerful base technology, such that users are able to make use of it in a way that really doesn't go far beyond the user interfaces and the modes of interaction that they're already accustomed to and capable of.
So basically you've abstracted all of this complexity of the AI deployment and design underneath the interface for the examiners.
Indeed, there's not going to be a single examiner who needs to run a script or program in order to make use of these AI capabilities. That's not to say there are no transition hurdles, because there certainly are. It's still going to be a bit of a paradigm shift to go from thinking about documents in terms of purely keywords to this messier concept of semantic meaning. But it's certainly something that we're